All right. Numbers 72 to 76. When I look at them, I immediately see that they're right triangles. And we've actually already answered a lot of questions about right triangles. When we answered questions earlier, we were able to use the Pythagorean theorem or our special right triangles. These problems are different because we're not asking for a third side when we already know two. So the Pythagorean theorem is out. And we're not able to use special right triangles because none of the angles are 30, 60, 90 or 45, 45, 90 degree angles. So when we look at these problems and we realize that we are looking at right triangles and they cannot be solved using the other options we just talked about. Missed a big step right there. We are expected to use the trig that we learned, specifically involving the SOHCAHTOA. Whoa, okay. So, SOHCAHTOA was our way for memorizing the three different trig functions, sine, cosine, and tangent, and what sides we needed to use to set them up. So what I'm going to do here, we talked in class about using a node chart, but I'm going to kind of streamline that here. I'm always going to look for my angle first, and my angle here is 40 degrees. And across from 40 degrees would be opposite side. Across from the 90 degree angle would be the hypotenuse. So I'm labeling right on the diagram. Okay, so we have our angle, and we have opposite and hypotenuse, which is the first term right up here, S, which represents sine. So we know that the sine of 40 equals opposite over hypotenuse. In order to solve this, we're going to need to multiply both sides by 12 to get rid of that 12 in the bottom. And if I multiply both sides by 12, I get 12 sine 40 equals x. All right, make sure that your calculator is in degree mode because it will not work if it's not in degree mode. Type in 12 sine 40 and you will get that x is equal to 7.713. Next problem, number 73. Once again, we're going to need to use SOHCAHTOA. I'm going to identify my angle. This time I don't have the side across from it, but I do have the hypotenuse, and I do have x, which is not across and so therefore must be adjacent to it. All right, which one uses adjacent and hypotenuse? That would be cosine. So the cosine of my angle is equal to adjacent over hypotenuse. In order to solve for x here, I must also multiply by the 40 to get it away from the denominator. This is only because x is in the numerator. X therefore equals 40 cosine 52. Type all that into your calculator. 40 cosine 52. And you get that x equals 24.626. Moving on to number 74. I'm still identifying my angle first, although now my angle is x. Opposite from my angle is 14. Next to my angle is adjacent. And I know it's not the hypotenuse because it's not across from this 90 degree angle. The trig function that uses opposite and adjacent is tangent, the t right over here. So the tangent of my angle equals opposite over adjacent. All right, now we want to solve for x. We always are solving for x, but x is caught up here with this tangent, and we want to get rid of that tangent function. To remove a function, you can't just add or subtract it. You have to undo it with its inverse function. And in our case, the inverse function is the inverse tan of x. Taking the inverse tan of tan cancels them out. Taking the inverse tan of this side, we need to do it to keep the balance. So x now equals the inverse tan of 14 over 17. Type it in your calculator, second tan, 14 divided by 17. And you find out that x actually equals 39.472. And since it's an angle, that's degrees. All right, number 75. We still have our x. Across from our x is opposite. Across from the 90 degree angle is the hypotenuse. And so we are going to need to use sine because that uses opposite and hypotenuse. Once again, we're solving for x, so it's the sine of x equals opposite over hypotenuse. Like the other problem, we need to get x away from the sine, And the only way to get rid of that sign is to do the inverse of sine, which is sine to the negative 1. I must take the sine to the negative 1 of this side as well. I end up on the left-hand side with x because they undo each other. The sine to the negative 1 of 6 over 11 is what I need to type into my calculator. Second sine, 6 divided by 11, x equals 33.055 degrees because it's an angle. Last but not least, we're going to do number 76. Our angle is x. We don't know opposite. We do, however, know the hypotenuse opposite that 90-degree angle, which leaves 7 to be the adjacent side. Adjacent and hypotenuse are a and h. That goes with the cosine function. So the cosine of angle x equals adjacent over hypotenuse. We want to get rid of the cosine function. Just like the others, we want to free x, and we only have to do that by doing the inverse of cosine. Do the inverse of cosine of 7 over 8, and we end up that x equals inverse cosine 7 divided by 8. Type that into your calculator. Second cosine 7 divided by 8. And that gives us that x is 28.955 degrees.